And it's now recording. Here we go. Let's see if anyone remembers. Before you add or subtract fractions, what do you have to make sure? Let's go with Lucas.
You have to make sure that the denominators.
Beautiful. Denominators have to be the same. Why? Why does it have to be the same? Wait. Say that again. I just didn't hear. Not sure, Sully? Why do they have to be equivalent? They're not the same. That's one of the key things I need you to understand. I don't want you to memorize it as what you have to do, but you have to understand that when you say divide 5, you're dividing something by quantity of 5 is different to dividing it by 4. It's like saying if you had $1 in your pocket and you had to share it between 5 friends or share it between 4 friends, everyone gets a different amount. Or if you think about a pizza, a whole pizza, if you cut it into 5 pieces versus 4 pieces, they are different sizes. That's why you can't group them together, because they are different. Just like an A and a B, they are different letters. So first thing, you're right, you need same denominators. But to have the same denominators, you need the lowest common multiple. What's the lowest common multiple of 5 and 4? Let's go. Yes, Ashwin? 20. So go through your 5 times tables and your 4 times tables. It's 20. But to get 20 in the bottom so that they're the same type of fraction.
What do you do to the bottom? You do to the top.
Very good. So 5 times what gives you 20? 4. So what do you do to the bottom? You do to the top. So at the top there, 4 times 2 is 8. The other one, 4 times what gives you 20? Let's go with Bo. 4 times what gives you 20?
4 times 5.
Good. And what if you do to the bottom? You do to the top. So 3 times 5, which is 15. Now the denominator is the same. You can say, how many of these 20ths do you have? You have 8 plus 15 of those 20ths. You don't add the 20s. It's not out of 40, okay, because we don't have 40ths. We have 20ths. So together, 8 plus 15 gives you 23. So you should have 23 over 20. Or sometimes the back of the book likes to write in mixed fraction. What's this as a mixed fraction? 1 whole, because 20 fits into 23 once and has a 3 remainder out of 20, right? This is the proper way of doing your fractions. Last term, I did teach you a shorter way, which I don't like teaching unless you understand this theory first. So if you get that theory, then here's a shortcut. It was called cross method. 2 over 5 plus 3 over 4. Anyone remember how to do the cross method again? What do?
You cross them out.
So which one do you pair with?
2 and 4.
2 and 4?
You cross both of them out and you put 1 and 2.
Very good. So 2 and 4, 5 and 3. And then remember, you also connect 5 and 4 on the bottom. Wherever the lines are connected, you times them together. So let's do it. 4 times 2, we already wrote before, was 8. There's a plus sign in the middle. And then you do 5 is connected with a 3. So 5 times 3, which is 15, over. And then notice that 5 and 4 are connected on the bottom there. So 5 times 4, which is 20. Interestingly enough, you're at the exact same step there. So that's called the cross method. So for some of you, the cross method might be more similar or at least easier to do for algebra. Okay? So that means you still get the same answer, 23 on 20. How do you do it when you don't have 2 fractions? What about 11 over 5? Take away. Now, how do you change 2 to a fraction, Tilly? Very good. Before you get to 10 on 5, you would convert it to a fraction, which is 2 over 1. And then from here, we know that to get the same denominator, what's the lowest common multiple of 5 and 1? Can I please have, yes, Mateo?
5.
5, very good. Lowest common multiple is 5. So this is already a 5. You leave it as 11 on 5. Take away. Now, to get a 1 to become a 5, you have to times 1 by 5. Whatever you do to the bottom, you do to the top. So 2 times 5 is 10. 10 on 5. And now we subtract them. 11 take away 10 on 5. gives you 1 and 5. Now that's a quick revision of chapter 3, what you did last term on fractions. We're doing the same thing, exact same thing, just with algebra. So it's just with letters. So you have to know like terms, yeah? So here we go. Let's practice. Let's have a look at the first one. Let's do this one. So you got a over 2 plus 2a over 3. Now to add these fractions, what do you have to make sure again? Same denominator. It's the same problem. This is a 2, that's a 3. What's the lowest common multiple of 2 and 3? Let's go with Haushan. 6. But to get 6, what do I multiply the 2 by? Can I please have, man? 3. Whatever you do to the bottom, you do to the top. So that means this is now 6 on the bottom, but 3 times a can be written as 3a. Not 7. Oh, but did you add? No, you haven't added yet. So next one. We need to change the 3 to a 6, so we times that by 2. Whatever you do to the bottom, you do to the top. That means 2 times 2a. What is 2 times 2a? I know. 2 times 2a. What does that give you? 4a. Very good. So it's 4a over 6. Now it's the same denominators. You can add the numerators together. So if you add them together, it's 3a plus 4a on the top. Out of 6, just the same way that we were doing before. Notice in exercise 5C, we said collecting like terms. 3a and 4a are like terms. They both have an a. What's 3a plus 4a equal to? 7a. So 7a over 6 is your final answer. So far, so good? Good? Is that why you said 7 before? Oh, 7a. All right. Here's my last example for today. I want you to do this using cross method now, so let's do it again. 2x, you can write as 2x over 1 plus x over 5. Now you can use the cross method. Cross these and cross the bottom. Wherever you're crossing, you multiply them. So let's do it. 5 and the 2x. What's 5 times 2x? 10x. So I write 10x on the top, but then I also cross 1 and the x. What's 1 times x?
1x.
1x. Very good. Divided by, and then on the bottom, 1 is paired with a 5 down here. What's 1 times 5? 5. So on the bottom, it's a 5. But if you look at the numerator, can I add 10x and 1x? Yes, they're like terms. So what's 10x plus 1x? 11x. So your final answer is 11x over 5. That is today's lesson. So we're combining. Can you see in the same one question, you're actually doing two things. You're doing exercise 5D, 5 times 2x, that's multiplying. And then in the numerator, you're doing collect terms from 5C, you're adding. 5E is combining them all together. So if you can't do 5C, you can't do 5D well, then that one goes wrong. Okay, so that's why they're always a building block. Every exercise you do is meant to help you for the next exercise. So if you're not keeping up as I'm going through, it gets a bit trickier. So build the foundation, work on 5C, work on 5D. Don't make those mistakes. Make the distinction between times and addition, and then 5E's fractions. Good?
Yeah. I wasn't here last lesson, but this said for 5 days.
Oh, well then I'll sit down with you. Well, it's good that you answered those questions just now. Yeah. All right, team. So there's last two examples for you to try. Otherwise, you can work on the exercise. I want to pause the video there, but I'll write the solutions later if you want to try and see if you got the right answer or not. Okay? Sorry? No, I like you there because it's just. You can use your laptop for today. Okay, but next lesson I want you to bring your book. Okay?